Good day, professors. This is our group presentation video for the course Blockchain Development Fundamentals. To begin, let me introduce our team members and presentation sequence for this video. My name is YingZi, and I will start with the project overview and problem statement. Next, YingZi will explain our system architecture and technology design. Then, Wenjun will provide an in-depth analysis of our smart contract logic and security. Finally, Muzi will conduct the live demo and evaluation. Now, let's look at the motivation behind our day app. In traditional web applications, transaction records and operational logs are usually managed by a centralized system. These records are stored in private databases, which makes it difficult for users to independently verify transaction history. In financial scenarios involving deposits and transfers, users must rely on a central administrator to ensure the integrity and accuracy of transaction data. In addition, centralized logs may be modified or deleted without leaving an immutable audit trail, which reduces transparency and accountability. To address these issues, our use case focuses on transaction and deposits logging using blockchain technology. In our day app, users can record transfer and deposit information directly on the blockchain. This ensures that the records are immutable and publicly verifiable, providing a transparent and tamper-resistant way to manage transaction logs without relying on a trusted intermediary. Next, my teammate will introduce the system architecture in more detail.
Hi, I'm YingZi. Let's start with the system architecture. The workflow begins with the user interacting with the front end. However, it is important to note that the front end cannot write directly to the blockchain. Instead, they sign a request to the wallet. Here, the user must explicitly sign the transaction. This signature authorizes action before it is broadcast to the blockchain to trigger a smart contract. Then, the technology stack. For the front end, we use web3.min.js for Web3 development. And for infrastructure and tools, we use MetaMask as a wallet. And we deploy the contract on the supported testnet to simulate the main network. We also use Render as a hosting platform to automatically deploy our front-end application. Finally, for the smart contract, we wrote our core logic in Solidity using the Remix IDE. Next, smart contract features. Our system focuses on two main capabilities, transfer money and deposit money. The primary goal here is data immutability. Once a record is confirmed on-chain, it is permanent and cannot be tampered with. Then, the contract structure. Regarding data storage, we consciously adopted the single record pattern. Instead of using complex mappings, we utilize direct state storage. We chose this concept structure for a specific reason, to clearly demonstrate the atomic nature of state changes. It allows us to show exactly how a transaction updates the global state without the complexity of historical indexing. Then, the key functions. We implemented this logic through two types of functions. Setup functions like transfer money and deposit money, and view functions like transfer view and deposit view.
Okay, my name is Wenjun and let me continue. For security, we utilize the address binding to link transactions directly to wallet identities, and storing data on the affiliate testnet ensures total immutability. Additionally, Solidity 8.0 built-in protections prevent arithmetic overflows and maintaining state integrity. And our logic uses direct state storage to minimize the on-chain overhead. By marking query functions as view, we enable users to retrieve transaction data with zero gas fee. This streamlined approach optimizes both cost and execution speed. And the system is modularized into two core logics, the deposit and the transfer. And the deposit money and the transfer money functions directly handle on-chain state changes. Meanwhile, the app.py backend independently manages local login logs, decoupling on-chain data from local records. And then it's an end-to-end user experience flow, and the flow covers everything from login to MetaMask signing, and we implemented an asynchronous wait mechanism, and this ensures network confirmation before data display and eliminating zero address errors.
My name is Zhang Muzi. Next, I will demonstrate our D app and then give a brief conclusion for this presentation. First, we can open our D app in the browser. It has already been deployed on the server. In this page, we can enter our username like user1 and log in. First, we can try to deposit money. We can choose a test account, copy from Remax, and enter an amount like 100. Click deposit money and confirm. After a few minutes, we can click the view transaction and see the record. Then we try the transfer money. Enter our address and choose another account as our payee address. Enter an amount like 10. Click transfer money. Confirm. Few minutes later, click view transaction. We can see the transfer record. Then we can go to the user log page. We can see all the login records. And when we click delete user log, all logs are deleted. And when we back to user log, it's empty, means that all the records have been removed from the database. And we can log out. That's all. To conclude, in this project, we implemented a simple but complete hybrid D-app architecture. It bridges a standard Flask web interface with a solidated smart contract on the Sepolia ETH test network for simple financial operations. During development, we faced several integration challenges, such as connecting Remix and MetaMask, passing parameters correctly between pages, and avoiding duplicated login records. Solving these issues helped us better understand how the front-end, the wallet, and the smart contract work together and how on-chain state is persisted in practice. At the same time, our prototype still has clear limitations, including a simple login mechanism and limited front-end validation. In the future, we plan to improve authentication, add better input validation and UX, and support more networks or tokens. Overall, this assignment gave us hands-on experience with the end-to-end the app workflow and deepened our understanding of Web3 development. That's all for our presentation. Thank you.